Okay, so we're doing another problem. Here's our all-important formula. So we're just trying to figure this out, and the most important thing is to realize that we're dealing with two different, we've broken it up. So you got one here and one here. Oh man, I can't do it. One more time. There we go. Alright, so let's do C1 first. So C1, we have to write it in parametric form first. So in parametric form, what is this going to look like? Well, it's going to be t, because t is variable, and t squared. Right? So t is variable, and they've told you up here that C1 is a parabola, y equals x squared. So it's like that. And they've also told you that it exists between 0 and 1. Now we also have to find dr dt, and that's just going to be one and 2t. Easy. And we also have to realize that based on this parametric equation, our x value is going to be t, and our y value is going to be t squared. Okay, now we're going to solve ds, and we know that ds is going to equal this. So ds is going to equal the absolute value of our derivative, so 1 squared plus 2t squared times dt. So this is going to give us the square root of 1 plus 4t squared dt. Therefore, we can write C1. Oh, we shouldn't really write it like that, should we? C1's area, so C1 of 2x ds of 2x ds equals, it was between 1 and 0. We know that our x value is t, so we're going to times this by t. And we also have to times it by the absolute value of this dt. And that is as far as he went in the lecture. So let's just leave it there. Okay. Now, let's do the same thing. Alright, let me rub this out. So that's for one of them. I don't know if I should rub it. I'm going to do it. Be brave and shave. Come on. So now we're going to do C2. And C2 is a straight line connecting 1, 1 and 1, 2. So, okay. That's laggy. D2, R of t is going to be, well, our x is a constant, so it's always going to be 1, and our y value is going to vary in regards to t. Woo, it's going to go up and down. So it's just going to be that. And they've already told us that it's bounded between, what is it bounded between? 2 and 1. Or 1 and 2. So I should not put the 0 there. It will be 1 less than or equal to 2 less than or equal to 1 less than or equal to t less than or equal to 2. Alright, we also need to find what ds is equal to, and we should know that, so that means we have to figure out what this is. So this is going to be 0 and 1, because the derivative of 1 is 0 and the derivative of t is 1. And from this parametric equation we can see that x equals 1 and y equals t. We also have to find the absolute value of the derivative. So that's just going to be the square root of 0 and 1. 1 squared, square root of 1, 1. And then we come over here and we put it all together. So we go c2 of 2x ds is going to equal to, between 2 and 1, 2, because the 2's here, times by our x value, which is 1, times by, which is 1, times by our, times by this, which is 1, and then dt. So it's just going to be 2, 1, 2 dt. And that's what he got in the lecture.